What's up YouTube? Welcome to my channel Mathlete. This is me, Saad, and today's video is on one of the most anticipated topics. I've had a lot of requests from you guys to make a video on symmetry, so it has taken me weeks to put it all together, as you can see. So without wasting any further time, let's get straight to it. Alright, so two-dimensional symmetry is divided into two main components. One is rotational symmetry, which is what we're going to be discussing right now, and the other is reflectional symmetry, which we're going to do later. So now let's talk about rotational symmetry. A shape has rotational symmetry when it looks the same after some degree rotation, right? And there's something else we need to know, and that is called order of rotational symmetry. Alright, you might want to write this down. Now, order of rotational symmetry is the number of times a shape will map onto itself in a full 360-degree rotation. Alright, I can repeat if you want. Order of rotational symmetry is basically the number of times you'll get the exact same shape in a full rotation, in a full 360-degree rotation, right? So here I have 5 shapes, right? And then what I'm going to be doing is I'm going to be one by one rotating every single shape about a fixed point, a full 360 degree. And then we're going to count, and you're going to count with me, the number of times we get the exact same shape, right? And by the way, bear in mind that this pentagon, this triangle, this octagon, they're all regular polygons in the sense, I mean the ones that I've made here, in the sense that all the 5 sides of this pentagon are equal, all the 3 sides of this triangle are equal, and all the 8 sides of this octagon are equal, right? So let's get started. So I've marked a red spot here for reference, which means that I'll stop when this point is back at its original place, right? So I'm going to start rotating, and then I want you guys to count with me. So that's once, this is now twice, thrice, 4 times, and then finally 5 times. So that means a pentagon, a regular pentagon to be precise, has a rotational symmetry of order 5. Alright, now let's talk about this parallelogram that I've made here. Again, this is the fixed point through which that I'm going to be rotating it. So no luck there. Let's keep on going, and finally we get the exact same shape. So that's once. So no luck. Let's do it again. That makes it twice. So that means a parallelogram has rotational symmetry of order 2. Now, at this point, I'd like to point out that you should also know, after you figured the order of rotational symmetry, the number of degrees you need to rotate in order to get the exact same shape. Now, there's a very simple formula for that. What you're going to do is you're going to take 360 and then divide it by the order of rotational symmetry. So if I want to figure out the number of degrees I need to rotate a regular pentagon in order to get the exact same shape, so what I'm simply going to do is I'm going to take 360 and I'm going to split it 5 ways, which is the order of rotational symmetry of a regular pentagon. So that's going to give me what? That's going to give me 72 degrees, right? What about a parallelogram? I'm sure you figured it out before I did. 360 divided by 2 is 180 degrees. Now let's move to this triangle, this equilateral triangle that I've made here. Now here's my fixed point, right? So I'm going to rotate it from here, and so that's once, right? Let's do that again. That's twice. Now I need to get this red spot back to its original place. So let's do that one more time. So that makes it thrice. So that means I got the exact same shape 3 times. So a triangle, or an equilateral triangle to be precise, has order of rotational symmetry 3. And again, if you want to figure out the number of degrees you need to rotate, so that's going to be 360 divided by 3, which is equal to 120 degrees. Now, this 120 degrees, I should point out, is from the center, right? So from the center, if you rotate this triangle 120 degrees, you get the exact same shape, right? So let's talk about this rhombus here. Again, here's my fixed point. So that's a quarter turn, no luck there. So that's half a turn. Half a turn basically means 180 degrees, so I got the exact same shape. So that's once. Let's do that again. And that makes it 2. So that means a rhombus has rotation symmetry of order 2, same as a parallelogram, right? And again, the angle that you must rotate is going to be the same, which is 180 degrees. Now, here's an octagon. So again, remember, I need to get this red spot back to its original place. So that makes it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, and then finally 8 times, right? I'm sure you figured that out before I did. So an octagon has order of rotational symmetry 8, and again, if you want to figure it out, if you want to figure out the number of degrees that you must rotate, so for that I'm going to do 360 divided by 4, or 360 divided by 8, sorry. So that's going to be equal to what? 45, is it? Yeah, that's 45. Anyway, so that's all for rotational symmetry. Now again, this was just an introduction of what rotational symmetry actually is. Now I know you may be thinking that the questions are never so easy, so you know, what's the point of teaching all this? But then again, the idea is just to grasp the concept first. So once that is crystal clear, only then you guys will be able to tackle the questions efficiently. Right, so that's all for today. If you like this video, make sure that you give it a thumbs up, and don't forget to subscribe to my channel. And also don't forget to share it with your friends, classmates, and whoever you think can possibly benefit from it. I'll see you guys in the next video. Stay tuned.